Let's now look at the ReLU activation function, which is the rectified linear units. On the left hand side, we have the input values x that go from -10 to +10. These are the inputs to the neuron A, which in this case is using the ReLU activation function that is shown up top on the green box. The calculated value from this activation function is shown in the column A, where we can see that all the negative values are set to 0 and the positive values remain as is. And on the right hand side is a plot of the ReLU activation function shown by the blue color line, and the magenta dots are the values that are shown in the column A on the left hand side. So that's how the shape of the ReLU activation function looks like. Now let's go in Colab and see how we can use the function. The first thing we'll do is create a set of input values. X is equal to tf dot linspace. We want to go from -10 to +10, and we create 100 values, and then we calculate the activation. So tf.keras.activations.relu takes in the input value x, then we plot these values. So plt.plot x comma y, plt.grid, and we have plt.show, and we should see a nice curve or nice plot that shows us the ReLU activation function, which is right here. We can also calculate the values as we have been doing in past couple of videos using the relation that's given above, which is here we have to get the max value. So we'll say tf.math.maximum, a maximum of x and 0, and we'll plot that right here, plt.plot x comma y2, and this should be a overlay on, so it's an exact overlay on the blue line that we had. So that's how the ReLU function looks like. And if we want to compare this with the other functions that we have plotted, let's plot a couple of those. Here's what we'll do. We'll copy this and paste it right here. And in this, we'll change this to, let's say, we'll plot ELU, which is the exponential linear units, and put the ELU here, and we'll plot the GELU with the GELU right here, and let's get them plotted right here. Y underscore ELU comma label is equal to ELU, and then we have this is label is equal to ReLU, and then copy this again and put it down below where we'll call this as the GELU. There are other activation functions as well which look similar to these two, so we'll just stick with these two for now. And when we run this, before we do that, let's print the legend, plt.legend, and here is what we get. So this is how the ReLU function looks like, and as you can see, the deviations at 0. So the blue line is the ReLU, the green line is the GELU, that's the Gaussian error linear unit, and then the orange line is the exponential linear unit. So the negative values are 0 for the ReLU right after the 0, whereas the Gaussian gives some room, then the values are closer to 0, whereas the ELU, it's much farther from 0 for the negative values. So that's how the ReLU function looks like. I will continue this discussion and look at yet another activation function in the next video. Until then, please like, share, and subscribe. Thank you.